G'day there. You're watching the Aussie BIM Guru, and today on the channel we're revisiting an old workflow, but as always we're coming back with new skills. So today I'll be going to be looking at creating and updating Revit sheets using the Revit API and Python in Dynamo. So this is a common workflow, but we're going to add a few new features to it and add a bit more control to the workflow. So first of all, we are going to focus on creating sheets from Excel, which is something we've done before, but we're going to do it mostly within Python, except for the collection of the Excel data. From there, we're actually going to be setting a parameter to sort the sheets as well from the Excel data, which we haven't done before. And we'll also be adding an option to update or refresh sheet data if there's matching sheet numbers found in the model. We'll create it so that it avoids common errors and issues that might occur in this workflow, mostly using Python. So today I'll be using Revit 2024 and the built-in Dynamo version at this time, and I'll also be using the DS Iron Python 2.7 package just so I can write in Iron Python. I believe this workflow should work pretty much the same way in CPython 3, but I choose to work in Iron Python. It is assumed you'll have some fundamental knowledge of Revit itself, a little bit of API knowledge, but I will try to explain all the API as I go. And as well as this, also just some basics in Python. I am going to be using my Python boilerplate, so if you're not familiar with that by now, if you search for my GitHub on aussiebimguru.com, github.com/aussiebimguru, there'll be a repo that should be titled miscellaneous. And you should find a Python template available in here, which is usually what I start every Python node with when working in Dynamo and Python. I'll also be using Revit API docs as well quite a few times today. Anyway, just jump back to the slides. There we go. Well, without further ado, we'll just dive in. Just a reminder, if I'm talking too fast, you can slow me down in the YouTube playback speed, because I know often this does happen, especially if English is your second language, or third, or whichever one it is. But thanks for watching in either case. Okay, so I'm just going to switch over, once I find my mouse, to Revit. So I'm just going to be working in an empty model, nothing special, no strings attached. So I've just loaded in a title block on a sheet. You will need at least one sheet with a title block on it, and we're going to reference this sheet and get its title block to use for the other sheets, rather than having to pick it from a big list of family types. As well as this, I do have a set of Excel data that I'll be using to drive my script. So in this case, I have the first column, which is sheet numbers, the second column, which is sheet names, and the third column, which is sorting data, which we're going to be using a parameter in order to effectively sort our sheets using. So you will want to make sure you have a similar structured file with one header row, which we will remove in Python. We won't transpose the data either. We'll work row by row. You'll see why as we work forward. So I'm just going to close my source, and I'm going to go to manage project parameters, and we're going to add a parameter, just a project parameter, to sheets, and I'm just going to call it sort, and I'm going to make it a text parameter applied to sheets. And what we can do with this parameter, which you might have seen in other videos I've done before, is if you right click on sheets and go to browser organization, we can create a sorting method. So I'll just call this sort, and I want to sort by that parameter. And that will effectively allow me to visually break down my sheets. So if I do want to break my browser up into series, I can use this parameter. So I can say this is, reference, and we'll see that it now sits under reference in the browser organization. So that will be used by our script as well as a parameter. So I'm just going to jump into Dynamo, and we're going to start scripting. So the first thing we need to do is actually import our Excel data. I'm just going to search for Excel, and I'm going to be using the OpenXML import Excel node. If you're in an older version of Dynamo, you might need to use the standard import Excel node. It does have some errors depending on whether your Windows install has been repaired, because it does cause issues when you get Windows updates. Sometimes it actually wipes out the required code that runs those nodes. So I do recommend the OpenXML import Excel node for sure. So from here, I'm just going to get a file path input. And I'm just going to make this an input by right-clicking it. Now I'm doing this part quite quickly because it's a fairly basic process in Dynamo, but I do have other tutorials on the channel of this nature that go in more depth at this part. So I'm going to plug in this as my file path, and I'm also going to get a string input and make this my worksheet input. And I'll just call this worksheet. So this is going to be the sheet that we're targeting in Excel. Usually I make this sheet 1 by default because that's the default in Excel. And at that point, we should have all our data. Now, I'm also just going to say start at 0, 0, and also read as string is true in a code block. Now, I could, of course, start reading from row 1 to skip the header row, but I'm going to skip the header row using Python instead, just to teach a technique that can do that. Now, we need two other things in our workflow. First of all, we need our reference sheet, which is going to be used for the title block reference. So I'm going to say use title block from sheet, and I'm going to pick my reference sheet. And as well as this, I'm going to get a Boolean input, and I'm just going to call this update existing sheet data. So this will be a control we can use if we'd like to refresh the data for any matching sheet numbers that are found in the document. You might not always want to do that. Maybe Excel is only correct to begin the process. Maybe you make some changes in Revit after that you don't capture in Excel. It's up to you, but this will allow you to do both. So I'm just going to get a Python node, noting I'm using IronPython 2 as the engine. You can always right click and make sure it's pointing to IronPython 2, reminding you that you will need to install the DS IronPython 2.7 package in order for that to work. I'm going to hit the plus button twice, and I'm just going to take in 3 inputs. So we got in0, in1, in2. So we're going to reference these quite early on in our script. Now, before I jump in, I'm just going to say sheet creation is the name of my script. And we're going to also watch an output for this, and this will just be sheets. Sheets created or found. And there we go. At the moment, we're just sending our data through because I'm using my standard Python template, the one that I showed on GitHub earlier. Now, I'm going to take most of this template out. We don't actually need a lot of this. We can cut out everything between the Common Language Runtime and Revit Services. We do need both the Document Manager and the Transaction Manager. I don't need Revit API UI or UI. We'll import all of the DB for now. I don't need anything but doc from there, so we're using document manager.instance.current DB document to get our current document to reference. I don't need any of my helper functions, so you can ignore that. And we're just going to cut right back to declaring our inputs. So I'm just going to zoom in so we can read this a little bit more clearly. And we're going to begin by actually collecting the inputs from our Revit model. So the first thing we need is our Excel data, which will be in the format of a list of rows of data. So to begin with, I'm just going to say Excel underscore data is equal to in0. So that's our first input to our Python node. Now what I'm going to do to this is do what's called slicing. So you might have seen this for indexing before, but what you can also do is take a set of data from there using what's called the column. And the way a slice works is you can take from the forward or the end, so from the front or the end of a list, or from a selection within the list by specifying the indices to work between. So I'm going to start from index 1, which will skip the first object in the list. Now with a slice, if you leave the back empty, it will go all the way to the end. So let's just pass Excel data through my Python node. And we can see that what we've done now is skipped the first object in the list when we've brought it in from Dynamo itself. Just a handy little syntax there. So you'll always work from left to right when indexing and sub-indexing or slicing and indexing. So at this point, I've sliced the Excel data as it's come into the node. As well as this, we want to get our reference sheet. Now this is coming in from Dynamo as a Revit element, so we do need to use the unwrap element argument. I think it's a function we'd call it. And we'll specify in1, which is our second object coming into the node. And as well as this, we also just want to get the Boolean or the true false of whether we want to update our sheets. So we now have our inputs. The first thing we need to do from here is get the title block from the reference sheet. So the easiest way to do this is probably to use a filtered element collector that is looking at the sheet as a view and to get the first element that is of the category title blocks. Now let's actually go to Revit API and figure this out. So the first thing I said there we're going to use is a filtered element collector. Now if you haven't seen these before, they're very useful. They're used a lot when working with the Revit API. They effectively find elements in the model that satisfy a provided condition. So in this case, we're going to be constructing a filtered element collector based on the document and the current view ID, which we have as the reference sheet. We're also going to be providing some arguments to it. So the first one is going to be the of category method, and this is going to be targeting the built-in category of title blocks. As well as this, we're also going to be asking them what is the first element that you get once you have this title block. So what we need to look at now is how do we find title blocks? Well, let's look up title block, and we can see OST underscore title blocks with capital T and B is the built-in category enumeration member for the built-in category. So we can actually target this built-in category. So let's do this first. So I'm going to get built-in category, and I'm just going to create a comment and say get title block. And I'm just going to say BIC underscore TTB. Now this is sort of what I like to call a global constant. I use it around the script in various places, so I tend to put it in all uppercase. And then I'm going to say this is built-in category dot OST dot underscore title blocks. This will now reference that member of the enumeration of built-in category. From this, we can now construct our filtered element collector using the methods we've looked at. So let's say TTB underscore ID equals to filtered element collector. And we're going to take in two arguments because we want to target the sheet as a view. So I'm going to say doc, which we've declared earlier. And then I'm also going to say sheet underscore reference dot ID. So we need to get the ID of the sheet. Now at this point, I'm just going to put a special syntax here. I'm going to do dot backslash, which means I can start the same statement, continuing it on the next line, just to keep things visually readable and not too wide. So I can continue chaining my methods at this point. I can add more methods. I'm now going to say of category. So we want to get all elements of category in view of BIC underscore TTB. So we want them to be the built-in title block category. And then we also want to get the first element. Now we don't want to get the first element ID because what this is going to return is the title block instance. What we actually want is the title block type ID. So there's a very easy way to do this. Title blocks fall under the element class. So in this case, we can use any method available to elements, and there is a method called getTypeID with no arguments, which effectively will just return the ID of the type of the element, and this will return the title block type ID. So we now have this, which we can use later when creating new sheets. So pretty much from here, we also need to get all the sheet numbers in the model so that we can check if the sheet numbers coming from Excel already exist in Revit and get that sheet that it represents if so. So I'm also going to say sheets underscore all is equal to, and I'm just going to copy the front of this filtered element collector. And in this case, I'll just go to new line. So we're going to now use of class instead because view sheet is a class. So sheets fall under view sheet. And we're going to be using some view sheet methods quite soon as well. So we'll just make sure we're here. But we can target this as a class instead of a category, which is a little bit easier. We're also going to be using the create method for sheets quite soon as well, which takes in the arguments of the document and the title block type ID, no sheet name, no sheet number, and this will allow us to create new sheets as well. So I'm going to go of class view sheet, and we're also just going to turn these to elements. So this will just give us all the sheets in the model. We can quickly have a look at these just to make sure it's working. We should only have one sheet technically, which we do. So at this point, I'm now just going to get all the sheet numbers in the model. And I'm just going to use what's called list comprehension to do this. So I'm going to open up a square bracket and I'm going to say s.sheetNumber, which is the property for sheet numbers of sheets, for s in sheets all, and close the square bracket. So this is basically just a short way of saying, numbers all is an empty list for s in sheets all, numbers all, append s.sheetNumber. So that whole block of code is effectively the same outcome as this comprehended list statement. So I do use these quite a lot when I'm basically just generating a list of properties from a list of objects. So it saves a lot of time. Okay, so from here we actually want to create our sheets, and we're going to do this all within a transaction because we will be creating sheets and also modifying existing sheets. So we're going to say create and modify sheets. Remembering currently our modify sheets is set to false, so we don't want to modify sheets at the moment. So we do want to use that condition. So what I'm going to do now is work across each row of Excel data and take the properties as we go and use them to create, index, or modify sheets. So I'm going to say for row in Excel data. So now we're working across the name, number, and sorting property of each row in our Excel data. And firstly, I'm going to get the row data. So I'm going to say sheet number is equal to row 0. Sheet name is equal to row 1, or row the second object, and sheet sort is equal to row and third object, or index 2. So we're now going to have those three values available in each row within each iteration of this for loop. I can then say firstly, if it exists, get the sheet. Now what I might also do is just append these sheets to an output that we can then report to the user at the end. So I'm going to say sheets out is an empty list. So as we find these sheets or create them, we're just going to add them to a list as well, because it might be useful to have them beyond the context of this Python node. Maybe we want to do things to them after. So I'm going to firstly check, does the sheet number actually exist in the existing sheets, which we already have. So I'm going to say if sheet num, or number, is in numbers all. So if it is, we know it has to exist. So if we found it, well, we can get the sheet because we know it's going to exist. So I'm firstly just going to say ind, and I'm going to store an index variable here. So I'm going to say numbers all index. So I want to find where in numbers all does the sheet number exist. And because we generated those numbers from the sheets, they'll be in the same order, and then we can get the sheet at that index of that number. So I'm now going to say sheet is equal to sheets all at that index. So that's pretty much why we got those existing numbers, both to check if they exist and also to get the sheet that represents. Now, it's important to note, I'm going to be using the keyword sheet in quite a few places within these statements, because by the end, we want to end up with the sheet, whether it's new or whether it's created, or whether it's not created, whether it's existing. So we are going to be using that in every area of the statements here. Now, we also want to see, do we want to actually update the sheets? First of all, I might just append two sheets out, the sheet that we found. But now we'll see if we're not updating, make the sheet none. So we're going to say if we're not updating the sheet, then after we've chucked it in the list, so we do have it in the list, we're just going to make it nothing. And then we can check later on, if the sheet is none, then we don't want to update it. So we'll say if not update sheets. So in this case, if update sheets is set to false, we're then going to say sheet is equal to none. Now the sheet that we've just appended into sheets out is currently still going to be a valid sheet in that list. This isn't connected to the variable sheet, so it's a separate piece of memory. But otherwise, we're going to be now saying sheet is none. So that's what we do if the sheet exists. If it doesn't, then of course we want to create the sheet, which makes sense. So we'll say else, and now we're going to create a sheet, but we're also going to store it to the variable sheet, because the method to create a sheet will output the sheet. So in this case, I'm going to say view sheet. So again, just to revisit this, we're using the view sheet create method, which makes you call the class, specify the document and the title block type ID, and then from there we'll return the view sheet. So we're going to say view sheet dot create. We'll say doc and then title block ID, which we got before. Once we have the sheet, firstly we're just going to append it to sheets out, because we want to append it whether it's new or old, we still want it there. And then we're going to set the sheet number before we do anything else, because by default it will just come out with the next available sheet number. we actually have to set that separately from the creation of the sheet. So I'm going to say sheet.sheet number, which is the property of the sheet number, is equal to, and we're setting that property to sheet number. So now that we've got this, the last thing is we actually want to set the rest of the parameters as long as sheet exists. So remember, if we don't want to update the parameter for an existing sheet, we've already made the sheet none. So we can actually use a statement to do this. We can just say if sheet, because if something is none and we run it through an if statement, it won't run. It will treat it like a false value. So we'll just say if we want to update, go for it. So we're going to say if sheet. So as long as this is an object, it will proceed with this step. So first of all, we're going to say that sheet.name is equal to sheet name. This will set the sheet name, the sheet's name. As well as this, we're going to want to set the sorting parameter. Now, let's imagine we're in a new model and someone hasn't added the sorting parameter to the project. Well, that could be a problem. So we could go about sort of solving this in a few ways. The most complicated way possible is to go and programmatically create the parameter. The second most complicated way would be to check if the sheet has a parameter of that name. And the last one would just be to run it through a try except statement. And if it can do it, it does it. If it can't do it, it just passes. And that's the method I'm going to use. So I'm going to say try. And we're going to try and look up the parameter. So in this case, the sheets should inherit the lookup parameter method from the element class. So if we go down to lookup parameter, there we go, inherited from element. This is a method you apply to an object and you specify the name of the parameter that you're targeting. So in this case, we're targeting the sort parameter. So I'm going to take the lookup parameter method and I'm just going to try to get the parameter. So I'll just say par or par, which is usually what I use for parameter, is equal to sheet.lookup parameter. And then I'll look for the parameter sort. I'm then going to use the parameter.set method, which we can use by checking the parameter class. And we'll find under methods the set method option, which takes various types of arguments depending on the data input given. In this case, we're giving it a string or a text value. So I'm going to set this, in this case, to sheet_sort, except we will pass if we can't do that. So this will effectively update or set the sheet's name and then try to set its sort value as long as sheet exists. At the end, we just finish our transaction, and I don't need this block of text. And then we're just going to send out, instead of sheets all, we're going to send in sheets out. And that should effectively round out our script quite nicely. So let's just test it. I'm just going to make Dynamo a little smaller. And we should see sheets appear here. Of course, there's an error. Sheets all, that's right. Sheets out, sheets all. There we go. I had a typo on line 34. I think otherwise that should now work. There we go, and there's our sheets. They've been created, they've had their sorting values set, and that's put them under the relevant part of the project browser. Now let's just close the script and let's just change some values. Let's make the sorting value x123. Now this is obviously incorrect, it's out of line with our sheet data. So instead we can actually just go and rerun the script, but we're now also just going to update existing sheet data. And let's just get rid of a couple of the GA plans as well. So if I run this again, we can see it's recreated the 3 sheets that were missing, but it's also updated the values of those sheets that were now incorrect. Now I've also built this script to work with Dynamo Player, of course, as well. So as a final step, we can go to Dynamo Player and we'll just run it through there as well. But it's a very effective little toolkit that sort of runs through a few essential Revit API techniques. It's a workflow I really like teaching people with, and hopefully it's been useful. So in this case, I'm just on my desktop, and I'll just open up sheet creation, and we should see our inputs. Firstly, our file path. Do we want to update the sheet data? In this case, currently it's set to true. And we're using the title block from sheet unnamed in this case. And then finally, our worksheet name is worksheet 1. And again, we can just delete a few, run the script, and there we go. We can see it's just updated and refreshed all the data on those sheets. So quite a handy little workflow, and I hope it's been a useful lesson in the Revit API. There we go. So thank you for watching. If you want to find any of the scripts that I build, they're over on my GitHub, so feel free to check it out. And of course, feel free to like, comment, share, subscribe. You can contact me at this email, and if you have any video requests or comments, feel free to leave them down below. I look forward to sharing future similar videos with you in future. Thanks. Take care. Bye.